All right, today we're going to be talking about how rocks can tell us the age of things. More specifically, we're going to be talking about the law of superposition. Does anybody remember what the law of superposition means? You were just studying those notes, so kind of hope that you knew something about it. The law of superposition. Who knows what it is? Out of a class full of people, I hope one person. You know? Go for it.
It's like one horizontal layer.
Yeah, but which layer is older? Well, they're all sedimentary. But think of law of superposition.
It's horizontal layers that, if it's above it, it's younger than the one below.
So, Maya was right. And then Brianna filled in the blanks. It is about sedimentary layers. They're horizontal. But the law of superposition says that in undisturbed sedimentary rock layers, the ones on top are younger than the ones on the bottom. Like a stack of pancakes. The fresh pancakes are on top. The not so fresh pancakes are on the bottom. Is that relative dating or absolute dating? Oops. Is that relative dating or absolute dating?
It's relative, not your given.
Exactly. It's relative dating. I'm not giving a number. I'm not saying that this layer is 75 million years old. I'm just saying that this layer is older than the one above it. So it's relative. No numbers involved. So anytime you have the law of superposition, it's always relative dating. So the title of this page will be Relative Dating equals Law of Superposition. I abbreviate law of superposition in my notes. I put LOS. If you want to do that and you remember that's what it means, that's fine. So with the law of superposition, finding out how old rocks and fossils are, we're saying the younger layers of sedimentary rock are on top of old layers. Those layers build up over time. This only works for sedimentary rock. This will not work for igneous or metamorphic rock. There's too much movement involved with those rocks. So only for sedimentary rock. So we're still doing Cornell notes. We're still writing our question on the left side. We're writing our answer on the right side. Now the law of superposition, if the rock layers have been left alone, nothing's been messed with, this is a really easy thing to do. It's one of those things that are so easy you think you're doing them wrong on a test. You're like, that can't be the answer, it's too easy. But if everything is left alone and you're given a column of rock layers, you can go, oh, that one down there, that's the oldest. That one up top is the youngest. So what I did was glue that picture of a geologic column into the middle. And you don't have to be exactly like mine if you don't want to. This just made sense to me. And on that picture, you can see that layer A is how many years old? 750,000 years old, which sounds old to us. However, layer H is how old? 100 million years old. Which one's older? Layer H, the bottom one. So that is a picture that fits our law of superposition. As we go up in the column, the rocks get younger. And 750,000 years old by no means is, a young rock. But compared to 100 million years old, it's pretty young. So looking at that picture, these rock layers have fossils in them. So we've got a dinosaur, and then we've got some fish right here. Which one's older, the dinosaur or the fish? Which one's older, the dinosaur or the fish? The fish, how do we know?
Because it's underneath them.
Law of superposition says the older layers are at the bottom, the fish are in the bottom layers, so they're the oldest. So if you're a paleontologist and you dug up all these fossils in this column, you can tell me right away that the clam fossils are older than the frog fossils, but they are younger than the fish fossils.
What's above the frog?
I have no idea.
Maybe a bird?
Looks like another frog to me. Maybe a gecko, I don't know. So on the right side, I put oldest layer with the arrow pointing up to youngest layer. And when you're dealing with a geologic column, the older the rock is, usually the bigger it is, because all the rocks on top are the rocks we see on the surface of the earth. Little bits of rock, the gravel, the weathered rock. The older stuff is larger boulders, the bedrock. They haven't been weathered down in a long time, so they've been formed and not messed with for a long time, so they're big rocks. Some terminology I want you to be aware of in case you see it on a test. Usually, they refer to rock layers as rock layers. However, every now and then, you will get a word in there like stratum or strata. A rock layer, or pretty much a layer of anything, is called a stratum. I'm sorry, stratum is the singular. When I have a column that has multiple layers, those are all called strata. So I don't want you to see that word and be like, what? So on a test, you may see a question that says, which stratum is the oldest? And you're gonna be like, I don't even know what a stratum is, but now you do. Last bit on that page is what I said earlier. This simple A, B, C, D, E, F, G, H, layer upon layer, this easy, top is young, bottom is old, only works if these layers have not been messed with. If something has happened, like an earthquake or erosion or a volcano, that changes the game completely. That gets a little more tricky. When you're done copying down these notes, what I want you to do with your rock cycle page is when you cut it out, make sure you leave this tab right here, because you're going to glue just the back of this tab, put it over these notes, so it's like a flip book. We're going to save some room in our notebook. So like in mine, it doesn't matter which side you glued it on. I glued mine on the right side. But you can glue it in on either side. It just makes sense to me to glue it on the right side. So how many of you have been to the Grand Canyon? How many of you have seen pictures of the Grand Canyon? Know what the Grand Canyon is? So in Arizona, there's this giant hole here called the Grand Canyon. And the Grand Canyon was formed over millions and millions of years of erosion. It's about 2 kilometers deep. And it's a straight down drop. It is a great place to observe stratification of rock layers because it is all sedimentary rock. The type of rock it is some volcanic igneous rock that has been broken down into sediments and reformed into sedimentary rock. So I've been to the Grand Canyon like 3 times. First 2 times was awesome. 3rd time was after I had kids and suddenly I developed this extreme fear of heights. And they really don't put rails around most of the Grand Canyon. It's kind of just like up to you not to be stupid enough to fall in, which people do and they die.
Are you serious?
Seriously, like
How many people died?
several people a year die from either being they're staying too close to the edge and they fall in, or they're climbing on rocks they're not supposed to and they fall in. And it's like a mile drop. So
Of course you're gonna die.
you're gonna die. Hmm? Oh, Brian, I'll get it back over to you in just a second. All right.
Have they never bought component rooms?
They put it up in the most popular areas, but most of it they don't, because it's a huge canyon. It would cost way too much, and it disturbs wildlife to put up a big old fence like that. All right, turn your voices off. So scientists love to study the law of superposition at the Grand Canyon because you can see the layers of rock yourself. You don't need any special equipment. You don't need to dig anything out. It's right there for you.
Watch this section. Think about the forces that formed the Grand Canyon and how the evidence found in the Grand Canyon's layers helps scientists recreate the geologic history of the region. Almost 2 kilometers deep, 29 kilometers wide in places, the Grand Canyon winds through 446 kilometers of northern Arizona. The sheer size of the canyon, with its extensive and varied rock formations and multicolored walls, makes it one of the most awesome sights in the world. It is also an important place to scientists who study Earth's history. Although the exposed rocks in the canyon walls carry a geologic record of the past 1.8 billion years, the canyon itself is relatively young in terms of geologic time. The Grand Canyon is only a few million years old.
That's all.
The history of the land where the Grand Canyon is located can be traced back about 2 billion years, when this area used to be a great mountain range. Over hundreds of millions of years, the geology of the area changed and eventually became mountainous. For about 500 million years, the area was mostly underwater, and layers of sediment were deposited, which was eventually transformed into sedimentary rock. Later, the movement of Earth's tectonic plates caused these layers to be pushed upward until, about 65 million years ago, the area was pushed above sea level. From that time until the present, weathering and erosion combined to form the Great Canyon. How are we able to figure out how and when all this happened?
So they just said that the Grand Canyon area used to be covered in water until it was pushed above sea level by geologic forces. What kind of fossils do you think they'll find in the Grand Canyon? Fish, marine life. They may find some clam shells and be like, yo, we're in the middle of the desert. Why are we finding all this? That's how they know that this used to be covered in water.
The answer lies in layers of rock. The rock layers of the Grand Canyon follow the law of superposition. The oldest rock is at the bottom, and the most recent layers are near the top. Other factors, including the type of sediment, position of the layers, and fossil remains reveal important clues about the age of rock layers and help scientists piece together a picture of the geologic past. For example, why do we think that a great mountain range once existed here? Granite forms from molten rock, which is one way that mountains form. And schist is a metamorphic rock, often formed as a result of the tremendous forces that build mountains. The presence of these two types of rock is strong evidence that a mountain range existed here about 2 billion years ago. The layers of sedimentary rock were laid down while the area was under ocean water. Sandstone usually forms closer to shore, while shales and limestones form in fairly deep, quiet waters. The presence of these types of rock provide evidence that this area used to be the bottom of an ocean. As the sea retreated and the rock was exposed to air, erosion cut into these layers, changing the landscape dramatically. The plant and animal fossils found in these rocks also provide evidence by helping scientists determine the age of the rocks, as well as what type of environment existed here in the past. For example, this trilobite, an ancient sea creature, was found in a layer of sedimentary shale. Scientists know that this kind of animal lived more than 500 million years ago, so finding this fossil tells scientists that this layer of rock is 500 million years old. And it also provides further evidence that, at that time, this area was an ocean. This animation of a spider that lived about 270 million years ago recreates what scientists think caused these footprints in sandstone. Scientists believe that at that time, this area was a dry environment. It is this mix of Earth's geologic history, as well as sheer beauty, that has drawn so many to the Grand Canyon, like geologist John Wesley Powell, who took his team through the canyon by boat in 1869 and lived to write about it. His reports inspired artists and photographers, whose images led tourists to come view the geologic wonder. But above all, for scientists, the Grand Canyon remains an enormous window into the history of Earth. The Grand Canyon is a dramatic example of the power of erosion and other dynamic Earth processes. It also offers scientists the most extensive record of Earth's history found anywhere in the world, including outstanding examples of the law of superposition and the concept of unconformities. Because the towering walls reveal so many different layers of rock from different periods, descending into the canyon is like taking a trip through geologic time. For example, the presence of granite and schist, the canyon's oldest rocks, provide evidence that a mountain once existed here. The sedimentary rock formed while the area was underwater. Some rocks, such as sandstone, formed closer to the beach, while others, such as limestone, formed in deeper waters. The canyon's sedimentary rock also holds fossils that provide valuable information about what the land once looked like and how it has changed. Study of the Grand Canyon provides insight into the formation of western North America and how processes like erosion play a role in changing the surface of the Earth over long periods of time.
All right. Yes.
So the very first fossil, how do they know about what it was in the beginning?
Radiometric dating, which is what we're going to talk about tomorrow. All right, so if you ever get a chance and you're out that way, you need to go to the Grand Canyon because it's more than just a hole in the ground. Every time I go there, it takes my breath away how big it is. There's stuff that you can do there, like if you really want to, you could ride a donkey from the what they call the rim, which is the top, down to the bottom. The Colorado River goes through the Grand Canyon. It's because that was part of what the erosion forces was to shape it. You could ride, do like rafting down the river. People go hiking, go camping down in the canyon. I have not gone down into the canyon, but I have been to the canyon a few times. I do. So this was 4 years ago. Yeah, when Aiden and Logan were just about to turn 4. So you can see the rocks, the layers of the rocks behind us. That each layer is like a ring on a tree. You can date the time. you're burning, and it's funny because you gave it the fossil thing, which, you know, learned it all the time, so.
This because I want to do something less fun than making me have to learn all this stuff.
Oh, like you want to learn. All right, so all these rock outcroppings are part of erosion, but this rock is millions and millions of years old. This is about 1.5 miles down to the bottom from where I'm standing, and you can't see it, but there's a tiny line running through the canyon right there. That's a huge river. That's the Colorado River. It makes the Yadkin look like a shrimp. So that tells you how high up this is, because you can't even see the river at the bottom. And it's several of miles across. And usually on clear days, you can see all the way to the other side. So again, that little canyon right here in the middle, that's where the river is running through. You can't even see it from this high up. And here's the deal. People die all the time going here usually because they're foolish. And they'll sit there and climb out and try to stand on stuff like this and get really cool selfies and then fall and die. Like seriously, like trying to get a selfie is like the #1 reason why people like fall and die at Grand Canyon. Right before we went there last, some guy was standing too close to the edge and his hat blew off, and he reached out to grab the hat, fell and died.
But then again, you can't say anything because that is an instinct whenever your hat flies off to try to grab it.
So when I went with the kids, I was like, y'all see that Grand Canyon over here? Yeah, look at it. We're right here. We're not getting any closer. That's as close as we're gonna get. I was so paranoid. That is as close as I got, and I about had a heart attack doing that. My dad took the picture. I was like, hurry, okay.
Your foot can slip.
That's why I was like, quickly. What y'all don't see is that there's actually a ledge below that ledge. I'm not that brave. I need a backup. So there's like a ledge below that ledge. So this is about, I think right here is about 19 kilometers across, if I'm not mistaken. So you couldn't see that far Winston-Salem. The air's not that clear. All right, what I passed out to you, that half sheet of paper, each person should have one. There's 4 different blocks on there. These are what we're going to talk about, that if it's not perfectly across, what does that mean? So yeah, it's not straight, it's not as easy to read. So what do we do then? We can't just go, oh, that layer's on the bottom, it's the youngest. Well, no, not if it's all crooked. So the title of this, you can keep it going as the same title, but I titled it, What If Rock Layers Are Disturbed? And I don't mean like disturbed like y'all think that so-and-so is a little disturbed. Not that kind of disturbed. So look at the one that looks kind of like a little slide. Yeah, it bugged me. Copier messed with me. I was like, I can't have it. All right. So in this picture, it's hard to maybe but it's easier on y'all to see. Yep. The bottom one is 1, and then it's 2, 3, 4 to the top. So the oldest is 1, the youngest is 4. So I can't just cut out sections on this like I would if it was the simple law of superposition, easy to read. It would look like this, but that's not the case. If I did cross sections like that, I would have multiple layers in each of my cross sections because there's been folding. That means that rocks have bent or curved due to plate movement, and it's kind of made squiggles, zigzags in the rock. Sometimes it's very subtle, and sometimes it looks like a fingerprint, a big fold. Let me see if I can, there's a picture I had, let me see if I still have it. There we go. Today. There we go. So this is a section of rock that has experienced folding. So you can't just go straight across and date the layers anymore. That does not work. You have to follow the fault lines. You have to follow the rock lines. So it makes it a little bit trickier. No note, no nothing. Deontay, yeah, nope. No note, no cupcakes, nothing. Frozen coffee. All right. So folding is literally just folded rock. Plate tectonics have pushed rock around, made it so it's not perfectly straight. So scientists have to adjust the way they read it. Page 36, you will get from the book and we're on page 37. When you're ready to move on to the next one, you're going to cut out the one that looks like it has a V cut into it. This may be what looks like after a glacier has come through. The glaciers slowly move, and when they cut through the land, they leave this kind of V shape behind. It also could be where a river had run through, like the Grand Canyon. In that case, scientists have to deal with the issue of erosion. You get shifting gaps in layers from it being washed away or pushed away by glaciers. So it's still fairly easy to date, but you gotta take into account those irregularities. You gotta know that what happened there, the erosion, that's gonna affect the way the layers look. Layer number 1 is still the oldest. Layer number 4 is still the youngest. What other forces besides water and glaciers can move sediments? Say again? Absolutely. Especially in areas where they have a lot of desert areas where there's not a lot of trees to block the wind, that wind can really move a lot of sediments. Who's still working on folding? Like, you know, not folding, but, you know, the folding. So everybody's done with the top one? Okie dokie. I'll move on. All right. Intrusions. Think of intruder. Something comes in that you're not expecting. Maybe you don't want the intruder to come in. Oh, yeah, it's intruder. I hope not. An intrusion is when igneous rock pushes through the layer of the sedimentary rock. So now you have this different type of rock kind of messing everything up. The thing to remember about intrusions is that they are younger than the highest layer they push through. Even though they may be starting at the bottom, intrusions are always younger. So the only rock layer younger than this intrusion, this number 4 right here, number 5 is the only rock layer that's younger than that. Even though number 4 shares the same space as 3, 2, and 1, it's new rock. So it is younger. I will tell you the most common question about law of superposition on EOGs and benchmarks is they'll give you a really complicated picture and they'll ask which rock layer is the youngest, and I guarantee you they will have an intrusion in that picture. Because law of superposition is all nice and fun and easy until you start throwing in a layer of magma or lava to get in the way. Now, if that intrusion had reached all the way to the surface, it would be younger than any rock layer on that picture. It'd be younger than number 5. But it stops after 3. Bless you. That was cute. Now these are very simple versions of some of the test questions you're going to see. So we're starting off easy, and then we're going to see if we can get you able to recognize law of superposition no matter what. Who's still on erosion?
No.
Nope. Seth's just kidding. All right, last one. And my pictures are a little darker than yours. A little. So, and the last one are faults. When I tell you about faults in the earth, what do you think of? If I say fault lines. Wrong kind. What if I told you California sits on a giant fault line? What does California have a lot of? That has to do with the earth and tectonic plates. San Andreas Fault. Anybody seen the movie? Yeah. What happens in the movie? The earthquakes.
Oh, yeah.
Fault lines are where two plates meet, and oftentimes you get earthquakes at many of those fault lines. So in fault lines, which is what this is right here, this is a fault line. That fault line is where two tectonic plates have moved, and that movement has caused the rock layers to shift. So now layer B is a little bit up here and a little bit down there. And scientists have to know it's just in different positions because of the fault. Now looking at that picture, let me see what y'all think. Oh, okay, yeah, much better. So which, if you were a geologist, which layer would you say is the youngest in that picture? The newest. A is a good guess. Who else has an answer besides A? B. Why? What is D? Youngest. I've got A and I've got D. Why?
Goes up one.
Not that it goes up one.
Oh, because
What did we just talk
they're
about? in the
younger
previous
than
one?
the highest layer they're pushed through.
D is an intrusion.
It's because they're younger than the highest layer they're pushed through.
D is an intrusion, and intrusions are always younger than the highest layer they push through. This intrusion goes all the way through. So it is the youngest layer out of all those layers. You cannot see squat on mine, I swear. Look at y'all on. Those are nice. The tricky part about faults also, they can either be vertical, which is what this is, where the plates are sliding vertically against each other, or they can be horizontal, where the plates are sliding across each other like this. So scientists have to know where the fault lines are, how that affects the rock layers, and then they can date the rock layers. That's it for the notes today. What I want you to do for the rest of the class is start on this worksheet. You may work with your group. You're looking at rock layers. The letters are the rock layers. And the numbers are artifacts that somebody found in the layers. And you have to use the law of superposition to answer the question, like which one is older? Who created this? How do you know? So you're an archaeologist. Alright, pause. I know some of y'all still recording notes. Look at this question real quick. This is out of an EOG practice book. Observe these undisturbed rock layers, and what's the best conclusion? We're going to be working on some vocabulary for the EOG too, because some words, like I had somebody one time was like, it says, illustrate why these are blah blah blah, and she thought that meant like draw. The wrong kind of illustrate speed.
Oh.
So, A says rock layer 1, rock layer 3 are the same age because they contain the same type of fossil. Is that true?
No.
No, it is not. The shell in rock layer 2 is an example of an index fossil. No, not really, because you can find clam shells in lots of rock layers. Rock layer 4 is younger than rock layer 1. Rock layer 3 is older than rock layer 2.
Yes.
Yes, that is an easy one, if you don't ever think it. So that'll probably be the easiest question you'll see on the EOG about law superposition. But if y'all see that and you're like, if it's undisturbed, it's easy. When they start throwing in intrusions and faults and folding, then it starts to get a little tricky.
Number 2 says it is a well. Who do you think that's it has that line right? That is a line.
Looking at that picture.
Oh, you want to? Oh, I didn't know you wanted to do that.
Yeah, it's a well, so we know it's man-made. Alright, make sure your name's on it, tuck it in, your notebook. We'll be working on this again, and I'll give you a little bit of time in the fourth period, and then whatever you don't finish is homework. But it shouldn't take you too long to finish up.